Hello and welcome to Algebra Unit 4-1, Lesson 3 on piecewise functions. So our objective today is that scholars will graph and apply piecewise defined functions. So your first question might be, what is a piecewise function? So a piecewise function is a function that has different rules for different intervals of the function. That sounds sort of strange, right? So here's an example. In this case, when x is less than or equal to 2, so everywhere from here over, the rule is y is x plus 1. But on the other side of my graph, anything where it is greater than 2, the rule is negative 3 over 2x plus 6. So you see the two different lines, obviously. We see very different lines here. This line here has a slope of 1. This line on the other side has a slope of negative 3 over 2. Means for every 2 I move over, I go down 3. We can definitely see that slope. And if this line continued, it would intersect my y-axis at 6. Sort of see that, okay? So you can see that on there. And that's what a piecewise function is. So let's look at a piecewise function here. Water bill. Cheyenne's mother is reviewing the monthly water bills from the summer. Each bill includes a graph like this one shown here, which reflect the different rates charged for water based on usage. So they charge a different amount depending on how much you use. Several relatives visited Cheyenne's family in July, and their water bill more than doubled. Assuming that the water consumption is down here, right? This is our consumption. Did not double. What is an explanation for the increase? So let's look at this graph. I'm going to actually see if I can zoom in a little bit on this graph for you. So let's look at this graph a little closely. So you'll notice when your water consumption, which is in thousands of gallons, if I use less than 5,000 gallons, right, then I'm on this first tier right here. So my bill is going to be less than $5. So right here, if it's less, we're going to be less than $5. But if end up using more, I end up in this tier. If I use between 5,000 and 10,000 gallons, my prices start at $10 and go up to $20, depending on how much water I use. And let's say I use even more than that. Let's say I end up in tier 3 because I'm using more than 10,000 gallons. Then my price is shown right here. Notice it's getting steeper and steeper. They're charging me more and more money depending on how much I use. So looking at that, what is a possible explanation for why their water bill doubled even though their consumption didn't? Well, I think what happens is I think they must have crossed one of these thresholds. If you cross those thresholds, look at the big change you have in your water bill. You jump from only spending $20 to spending $30. Here I go from $20 to $30 very quickly. Here I go from $5 to $10 very quickly. Even though I didn't use double the amount of water, my water bill doubled. Okay? So let's talk real quick about domain and range with these. So, what is the domain of my water bill? Well, we're talking about consumption of water, so x must be greater than 0. But that's really the only constraint for our domain. Well, what about range? What is the possible range of my water bill? Well, I could have a water bill that starts at 0, and it could go all the way up. I mean, there's no maximum on the price. It can actually go up to infinity. Does that make sense? This one's 0 to infinity. Same thing with our domain. They're both 0 to infinity. We can't have a negative water bill. We can't have a negative water usage. Okay, so now let's look at another situation. We're looking at buying wristbands. So, a gym owner wants to purchase custom wristbands for a marketing promotion. She thinks she'll need about 75 bands. Her assistant insists that ordering over 100 wristbands will be less expensive than ordering 75. How can the assistant convince the owner? So let's look at this first. You see over here our price list for our custom wristbands. So if we order 0 to 50, they're $2 each plus $20 shipping. If we order 51 to 100, they're $1 each with $10 shipping. If we order 100 wristbands, they are 50 cents each plus free shipping. So let's fill in this table. So if I order 0 to 50, they are going to cost me $2 each. I have to multiply that times the number of wristbands, which I'm going to call X. And then my shipping is going to be $20. If I am ordering 51 to 100, then I trust is $1 each. So they're $1 each. Plus I still have to multiply that times the number of wristbands. And my shipping is $10. And finally, if I'm over 100 wristbands, they cost 50 cents each. Still have to multiply the time X. And I have free shipping, so this is going to be plus 0. Okay, so now that we know that, let's look at this again. So I did this with it, just looking a little bit nicer with it all typed. So, we still need to convince the owner that it will be less expensive to order 100 than 75. Why is that true? So at 100, we're at this price level here, right? Oh, this is over order 100. Sorry, so we're over here. 75, we're at this price point. Sorry. We can write each of these, this whole thing, as a piecewise function. The piecewise function would look like this. So we can see that this is our price, $2 each plus $20 shipping if we order between 0 to 50. It's 1x, we just don't write the 1, plus $10 shipping if we order between 50 and 100. If we order 100, it's going to be 0.5. So how can we convince our gym owner that they don't want to order 75, they want to order over 100? So let's take a minute and look at what a graph of this function would look like. So here's a graph. You can see on this graph that when you order between 0 and 50, you pay $2 each. This would be a very steep graph because our rate of change is 2. We have this very steep graph all the way up until we hit 50. Then if we order more than 50, so you notice we have the open dot here because we're at greater than, not equal to. Greater than, when we're equal to, we have the solid dot just like we did on our inequalities. So we have an open dot. We're going 50 to 100. This time our slope is 1. So we can see that if we order 75 wristbands, it's going to cost us $85. However, notice that if we order more than 100, look, my price, I started out lower. So we can evaluate this function at f of 75. At f of 75, we know that we're going to use this function. We have 75 plus 10 is 85. At f of 101, if you ordered 101 wristbands, we are going to use this part of the function. So 0.5 times 101 is $50.50. So the cost for 75 wristbands is $85. The cost for 101 wristbands is $50.50. So again, let's think for a minute about what the domain of this function is. So what is the domain of this function? Remember, domain represents our input. Input here is the wristbands. So we can order 0 wristbands all the way up to infinite wristbands, but they can only be whole numbers. Does that make sense? Because we can't order 5.3 wristbands. Well, what about the domain? The range. What is the range here? Well, what is my lowest price? My lowest price is $20. What's my highest price? You notice this arrow over here tells me that price keeps going up. So it could go up to infinity depending on how many you ordered. So my range is going to be 20 to infinity. Just a quick summary of what we've gone over here today. So, a piecewise function are defined by different rules for different intervals. Remember, intervals are always our x values. Here you can see in algebra, our boundary is 3. And we have different rules for the different parts of the function. And here's a graph of it. You'll see that you never have, these are not actually directly above each other. This is all the way to 3, and this is anything greater than 3. Okay, good luck with your classwork and your mastery check.